All right, so for the horizontals, there's 3 sets of rules you need to know. Bigger on bottom, bigger on top, and same on both. What is this one? Say it if you know it. Same on both, okay? So if it's same on both, it's y equals a ratio. What if it had been bigger on the bottom? What would be the rule then? You guys are weak.
It's on the outside.
So x over x, okay, so I'm gonna give you 3, and I want you to just do horizontals on these, and if you answer faster next time, maybe I won't think you're weak on stuff. That's bigger on the bottom, this is bigger on top, and this is same on both. Would you please tell me the asymptote you'd get for each of those? Just the horizontals now. Don't say them, write them. This is A, B, and C. All right, Zodi, tell me one of them. There's bigger on bottom, bigger on top, same on both. And then there's rules like one of them's y equals 0. One of them's there is no asymptotes. All right, then take notes on this. Seriously, these will hurt your test a lot if you don't know these. Let's go with Daniel Crocker. Why? How do you know it's y equals 1 though? Why isn't it like y equals 7?
Because it's a ratio
of these lead coefficients. Yes, it's a ratio of those. Okay, good. Then there's bigger on top. What's a rule for bots? The middle one's a bot. Yes?
that there is no asymptote.
None. And this one bigger on the bottom, y equals 0 unless something on the outside. And that's y equals whatever's on the outside. Like if you had a simplest one of that, it'd be like 1 over x. If you added 8, then the asymptote would have to have moved up 8, right? So y equals 8. And if there was an 8x out there, then it'd be a slant asymptote at y equals 8x. Angle instead of a horizontal. Okay, moving on. So here's our horizontal asymptote. This one's the same on both, y equals 1. Vertical asymptote. The verticals are what makes the bottom 0 unless they're a hole. So this factored into x plus 4 and, Carmen, what's the rest of it?
The rest of it is x minus 1 and x plus 4.
All right, x minus 1 and x plus 4. I agree. Then these two are going to cancel and create a hole, which goes right here, and it's negative 4, comma something. That's one of the hardest things, is to know what goes here. The hole does not automatically have a 0 there. The hole, you put this negative 4 in here. This function that results, y equals x over x minus 1, that's our simplified function. And it's the same as the other one except for the hole. So you put the negative 4 in there, and you end up with negative 4 over negative 5, 4/5. Raise your hand if you had 4/5. Okay, awesome. Now I'm putting it on my chart because it's a point. It's just a special point. I'd definitely label it as whole, so you don't by accident put a dot there. Okay, next up is the x-intercept. The x-intercept is where y equals 0. So if I want the whole thing to equal 0 here, then I want the top to be 0. What makes the top 0? If you put in a 0. So it must be 0. 0, comma, when you do put in a 0 for x, you get 0. Look at that. And if you think about it, 0, 0 is a very special spot because it's the x-intercept and it's the y-intercept. Okay, now the vertical asymptote. Verticals come from the bottom. What makes the bottom 0? X equals 1. Remember, these have to have an equation. You can't just say 1. You have to say x equals 1. And the verticals are the zerticals, and the horizontals are the horizontals. Don't confuse your y's and your x's. Domain. I like to draw out the number line because there's usually, everything works except a couple numbers. What are the two numbers that don't work? Because they make a whole or an asymptote. -4 doesn't work and 1 doesn't work. Why doesn't 1 work? Because it's a whole, no, because it's an asymptote. And why doesn't -4 work? Because it makes a whole. Neither one of those work. So, everything else works though. So the domain is all real numbers except -4 and 1. Now, if I were going to graph this, I would put in my asymptotes, which are at 1 and 1. And then I'd need a few more points. Well, I have a whole. That's kind of a point. -4 comma 4/5. So it's like here-ish. Oh, wait. It'd be underneath that line. That line is at 1. 4/5 is less than 1. So sorry. It's like here-ish. Just on that side of the line. Makes a big difference. Oh, and it goes through the 0, 0, right? Remember how 0, 0 could be on my list? So it goes through there. Oh, and then it gets closer and closer to the asymptotes. It's a no big deal. Okay, and then wouldn't it be nice to have something on both sides of the vertical asymptote? Yeah, so I need to get bigger than 1, so like stick in a 2. In this case, I might only need 1 extra point, so I'm going to stick in a 2. Where? In this one, just because it's easier. 2 over 2 minus 1. That's like 2 over 1, which is like 2. So 2 gave me 2. Over 2 up 2, put a dot. Yay. Goes like that.
And all this is gonna be on the test.
You have to know every single bit of that.
But it's a word problem.
Not all word problems. And if this were a word problem, it would just be something like, I don't know, we give you some sort of a word problem that would give you a, what do you call it? Basically give you this equation, a polynomial.
But didn't you say that it'd be 4 word problems?
Yep. There's still a way for that to be true. Okay, so just bottom line, I'm not wasting your time. You need to know this. All right. All right, moving on. The next one is a more normal word problem. Okay, so here's the words. My mom and dad were Bob and Sally, and Bob and Sally loved to pick blueberries. And so they did it way up on the border with Canada, and they found the good spots up there, and they did it in Wisconsin. And my mom was the pro. My dad would totally admit that. Sally was way better at blueberry picking. And you always set up a rate plus a rate equals a rate. So let's say that my mom was able to do 400 blueberries in 2 hours. Then she went out picking with my dad one time for a marathon session of 6 hours. And together, they were able to get 1,500. No, that's too much. 1,000. Nope, that's too little. Dang it. 1,500 would have worked. I'm going to go with 1,500. 1,500 blueberries in 6 hours. Now, the last part of this question is a little more tricky. Instead of just asking you, what is Bob's rate? I want to say, we have figured out that it takes about 200 blueberries to make a pie. How long will it take Bob to pick 200 blueberries? All right, set this up. Remember to keep your units in there, and then you can drop them out after you've set it up right. Because if you don't have the units in there, you'll get really confused on where things go. Yes?
I already got the answer.
Excellent. Just be patient. We're obviously not giving the answer yet. Okay, here's how it went. 400 over 2. And I'm not putting in the units, bad example, but I need to go fast, so. And this is where those units would be handy. We needed to pick 200 blueberries, so I've done blueberries on top. I'm putting them up there. And then the time, I'm going to use T for time. That way when I'm done solving, I'll know that I've got a time. Okay? And then I do some reducing, and this would reduce to 200. This, they're both even, so I could split them in half at least and get it down to 750 over 3. And 3 goes into 750. 250, isn't it? Okay, so then I got 200 over t plus 200 is equal to 250. Now I'm going to subtract, first got to multiply everything by t. Times t, times t, times t. Got to clear those fractions. That's a top 20 skill. 200 plus 200t is equal to 250t. Subtract 200t from both sides, and I have 50t equals 200. Divide by 50. And it's 4. Raise your hand if you had 4. Okay, awesome. All right, so that's the rate plus the rate equals the rate kind of question. How about boxes? Draw a long rectangle like that. Then make 3 black lines that are all parallel that go like that. Doesn't have to be black, I don't care. I'm just trying to show you how to draw the box so it looks somewhat decent. Making those 3 black lines parallel is the hard part. Okay, there. Decent looking box. Now I'm going to call this a volume question. Your boss has determined that you need to ship about 1,200 cc's, that's cubic centimeters, of volume. In your box, they want it to be, this is length, this is width, and this is height. They want your box to be 3 times as long as its height. If that's all I knew, I couldn't solve this question. So because I have 3 variables, I basically need 3 pieces of information. So far I got 2. Okay, so now I'm going to say, I think it would look nice if the height and the width were the same length. Height equal to width in this box. So if I were approaching a word problem like this, I would start with the master formula. It's clearly about volume. So then I would write V equals blah, blah, blah. And then I would stick in everything I knew. And then I would try to get it down to 1 variable. If you can only get it down to 2 variables, then you need a second equation. Like maybe they'll start talking about its surface area, and then you'll have to write an equation for that. So my point is if you can only get it down to 2 equations, they'll each have 2 variables in it. That'll work. 2 equations with 2 variables, you can do substitution and or elimination or graph both of them, see where they cross. You can find the answer as long as you have. But in this case, I think you can get it down to just 1 equation with 1 variable. All right. And if you're good at this, you're probably already done. Is there how many people are actually done already? Okay, then I'm going to give you a minute to think. So, volume was equal to length, width, height. I'm going to make a separate equation. Volume was 1,200. I'm going to make the separate equation approach because some kids will like this better. Then I'm going to write over here that 3 times the length is 3 times as long as its height. Length is 3 times its height. Okay? Next, height is the width. Well, h equals w then. Do you get I have 3 variables and I have 3 equations? That means it'll work. Okay, so now if h equals w, then I can replace the w with the h or the h with the w. That doesn't matter. So I'm going to go over to this one, L equals 3h. I'm going to replace my L with 3 h's, and then I pretty quickly realize it'd be nice if I could get them all into h's. So could I replace this w with some sort of an h? Yeah, w is h. So times h times that is h. So yay. 1200 equals 3 times h to the third. Divide both sides by 3. 400 equals h to the third. And do you get, if we had a nice clean third root of 400, that'd be great. But does anybody happen to know what to the third is 400? You got that?
It's 7.368.
All right. Now on a test where you don't have a calculator, which you don't, you'd be allowed to just say to the 1/3 power, 400 to the 1/3, or the cube root of 400. That would have been an okay way to end your problem. There's the height. Now, what if they wanted to make the problem more complicated? They could have said, instead of saying that the height and the width were the same, they could have given you some other formula that led to that. Or they could have said, here, I want to give you one last thought. You guys remember the cylinder? It's like a pop can. So, that's the radius, that's the height. Everybody tell me the volume of that one. It's not that hard. You always get the area of the base, and you multiply by the height. It's true for boxes, it's true for volumes, it's true for, it's true for cylinders. It's true for a lot of things. Rectangular boxes, cubes, all of those things. Take the area of the base, multiply by the height. So do you get what I was going for there is pi r squared times the height? Raise your hand if you had that one. Okay, good. Now, I'm going to start telling you a few things about in-limit notation that I want you to think through. What's the limit of the volume as, I can't say as x approaches something because we don't have an x in the problem. As h approaches infinity. Think that through. Think about what that really means. If you understand what it means, it's not that hard to tell me what the answer is. What's the limit to the volume as h approaches infinity? Raise your hand if you know this one. Okay, say it if you know it. Infinity is correct. Why? Because here's how you say it to yourself. As h gets bigger and bigger, what happens to the volume? So as h gets bigger and bigger, the volume gets bigger and bigger and bigger. And so is there any stop to this? No, so it's infinity. All right, now I'm going to make it slightly different. Now I'm going to say that we have a known volume. Like let's say that you're Campbell's Soup Company and you always put a certain amount of soup in your cans. It's just, like that's got to be that way. Okay, so that we want, let's say, 1,000 cc's of soup. Okay, so let's say that the volume is 1,000, period. So 1,000 equals pi r squared times h. Then what's the limit of the height as the radius approaches infinity? Remember, the volume is going to stay fixed at 1,000. The can's only going to hold 1,000. I'm going to pause for a second. You guys talk about it when you got it. So remember, the way you think about this is you say, as the radius gets what? Larger. As the radius gets bigger and bigger, what has to happen to the height? Why would a kid lose points if they said it goes to negative infinity? Because the lowest it could ever be would be what? 0. And could it even be 0? Okay, but you still could put 0. I know that seems weird, but it's true. Because if r can go to infinity, then this can go to 0. Okay, so you'd say 0. All right. Okay, last kind. You got a garden alongside your house. You want it to be super long and skinny. In fact, length compared to width, you want the length is 5 times the width. You looked it up and you figured out to get enough out of your garden to like feed your family for the winter, you are going to need 400 square feet. The question isn't quite as simple as what's the length and what's the width. The question is, how much fence are you going to need? Remember the black side of your house. We assume your house is big enough to always be long enough. And then you're going to put the fence around that. So you won't need fence on that one side. So how much fence? All right, pausing for a second while you try that one. Write out an equation, stick numbers into it, and if you need multiple equations, fine. Maybe you have 2 equations that both have 2 variables. That'll work. And one other way you could study, I'm going to actually post at least 2, maybe 3 videos from today's classes where all the problems are different. So in other words, you just went through a review, right? What if I did another whole review like that for you tonight? Well, you could do that because I recorded this same lesson in last hour with different problems and different numbers. Okay, so you could have the same experience last hour and the problems were all different. Okay, so if you watch that video, if you watch the video and you're like, wait a minute, that's the exact same thing we did in my hour, then watch a different one. Okay, talk to the person next to you, see if they got the same equation that you did. Don't even have to solve it, just see if they got the same equation. Okay, so how have I told you to start all the problems? All the problems start the same way. Yes? Yep, write the formula that's involved. This is about area, so area equals length times width. Okay, and then do I know some of those things? Yeah, I know the area is 400, so I put that. And if you just want to say, there's one of my equations, well, cool. Then you got to write like 3 equations and put them all together. But I'd like to just make a swap, because I know the length is 5 times the width, but maybe I should just write this to be careful. Does that mean L equals 5W, or does that mean 5W equals L? No, wait, that'd be the same thing, sorry. 5L equals W. And people get confused on this, I know. So think about it. Which one's bigger? L or W? Which one's bigger? L's bigger. So wouldn't you want to multiply the smaller one by 5 to make them equal? Yeah. So it is this one. Okay, so then L gets replaced with 5W. Cool. 400 equals 5W times W. That's 5W squared. I divide both sides by 5. And 200 equals W squared. Is that right? And then I do square root of both sides. Whoop. Nope, I'm wrong. Sorry. 400 divided by 5 is not 200 apparently. What is 400 divided by 5? Help me out. 80. Thank you. 80 equals W squared. And then I square root. And I get the square root of 80 and I'm all proud of myself. That was really hard and I got the answer. What is that? That's just the width. Okay. Then could you figure out the length from that? Sure. You know 400 is equal to the length times the width we just figured out, square root of 80. You could simplify that, by the way, but for right now, I don't really need to do that. Do you get how you could get L from this equation then? Then you'd know L, then you'd know W, and then you'd have to go 2 W's plus an L to get the perimeter. That's how much fence you'd need. Okay, so this was 1 W, was a square root of 80. Square root of 80, another square root of 80 down here. And our L was 400 over the square root of 80. And I'd say it was this times 2 plus that. Since I can't have a calculator, that's how I'd have to leave it. Yes?
Wouldn't it be if L equals 5W, then for the L you could just put in 5 times the square root of 80 and then add
Okay,
that
wait. Sorry. If there's something wrong with what I did, can you tell me what's wrong with what I did?
Well, doesn't L just equal, square root of 80 times 5?
Okay, so do you think that this can be simplified? Is that what you're saying?
I think that's an easy way to.
Okay, so there's another way to write that. I believe that. Do you get what I did? Was that 400 is equal to L times the square root of 80?
So
I mean, area, if area is length times width, then 400 is equal to length times the width. The width we figured out was square root of 80.
You just write 5 times the square root of 80. Because length is 5 times W, and W is 80 squared.
That might work.
Yeah.
All right, that's all I have for you for today. Have a great day.
Thank you.